Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I, Engineer Shad Muhammad, lecturer at Department of Civil Engineering, ComSets University, Islamabad. Welcome you all to this another interesting lecture. This will be our lecture number 17 of the subjects Mechanics of Solids 2. In our previous lecture, let me revise that briefly because today's lecture is interconnected with our previous lecture. And in our previous lecture, lecture number 16, we studied about how we are going to measure the stresses and strains with the help of some experimental equipment. And you can see that this equipment is sometimes called universal testing machine, and sometimes it is called mechanical testing machine. However, whatever its name you call, there are few basic functions of this machine are this, that it is capable of testing against tensile test, and it can conduct compression test and also bending test. And with the help of some additional assemblies, you can make it perform some additional tests too. So we discussed the sample specification, and then strain gauges and extensometer and load cells. We also draw the load versus deformation, force versus displacement curve, and how you are going to transform that into stress versus strain curve. So we studied about this in this lecture, and then we further categorize those curves into elastic behavior and plastic behavior. And moreover, then we studied failure and allowable limits on stresses, that how material fail and what are the allowable limits. Mostly yield stresses are allowable limits, and for ductile material yield stress is allowable, and for brittle material fracture stresses. And variety of stress strain responses we studied, and different materials will behave differently. And this was the data set: load versus elongation or displacement, and we were able to extract stress and strain from this one. So how you are going to do it, and make this graph using softwares. Today we will be discussing those things, and it's very practical, and it will be required by you in your final year projects and even in your term projects within your semesters. So let me open an Excel sheet, and I have this Excel sheet. Okay, before opening Excel sheet, this is University of Illinois documentation regarding stress strain data with Excel. Not so comprehensive document, just some overview of essential components, and you can download the data from this website, this link. Okay, open a new Excel sheet, enter the header data, enter the test data, and this is your test data, and this is your machine. What it gives says that position, this is the displacement, and this is the load, and this is strain and time. So it can, in this Excel sheet, can elongate almost 1000, 2000, 5000 data sets. Okay, then he has introduced how you are going to note the pi and area and pi d square, and definition of stress. 1 Pascal is equal to Newton per meter square. Units consistency is up to the experimenter who is performing the experiment, that unit should be consistent. Excel is unitless software. It do not know how you are going to make the units consistent or in which units you are working. Just it is going to multiply, divide, and basic mathematical functions it can perform using matrices. So 1 Pascal is equal to Newton per meter square. If your unit is not in Newton, then you can transform that in Newton, and if that is not in meter, then you can transform that in meter too. So stress is equal to load divided by area. Load is Newton and area is meter square. 1 megapascal is equal to 10 raised to power 6 pascal, and 1 millimeter is equal to 10 raised to power minus 3 meter. 1 millimeter square is equal to 10 raised to power minus 6 meter square, and these are the subunits. And stress megapascal is Newton per millimeter square. If your load units are in Newton, this depends on your equipment to equipment, that in which units it is measuring the load. If that is measuring the load into pounds, then it should be pound, and per inch square psi, and ksi is larger units. So if your load is in kilonewton and millimeter square, and you want to transform that in megapascal, then you have to multiply that with 1000, because you have to change this kilo. So these are stress units should be in megapascal. So these are the formulas. Erroneous data, improving appearance. Okay, that's it for Excel sheet, and let me move to some tactical thing, that is this is Excel sheet, and this is my own data regarding carbon fiber reinforced composites. This is your actual data set, and these are different Excel sheets and charts. Okay, let me select some data from here. Let me copy this and select a new blank sheet and paste it over here. Okay, this has been pasted. Let me delete this one. Okay, before deleting this one, I should be telling you one thing that is important. These are your formulations, formulation 1 or test 1, test 2, test 3, test 4, test 5, and this is actuator displacement and axial force. This is axial force, okay, and this is displacement, but your actual displacement was this one. It started from minus 22.44, but this, you can see that this displacement is in minus, so this is not the real value. So you have to make it positive. How you are going to make it positive? That you have to select a cell, and you have to place an equal sign and select this one, this cell, and you have to add equal value, that is 22.4411, and press enter, and you should be getting 0 over here. I have pressed 22.55, 0, and you should be dragging this value across all these cells, so you will get some refined data. Okay, we have already got this data here, and let me delete this one, delete this one, delete this one, delete this one. So 4 data sets we have, and how you are going to draw an Excel sheet, a chart from it. First we have to go to insert and scatter. These are scatter graphs, you can see over here. These are just dots, and this is line with dot, and this is just that. Let me select this one. It has selected this F3 one, and let me change it. Select the data. I have removed the data Okay, this is your empty chart. Now you are going to select the data, add a series. So this should be your experiment sample name. Okay, sample F2 and series X values. This is your first series, so I will choose select this one and drag it. This one and select this again. And now Y series. This one. Okay, selected and press OK. This name is fine. Okay. This is your graph. Now I should be moving this to move chart to another chart sheet, and this should be chart S1, S2, S3, S4. Okay, this one. This is the name of the chart. This should be sheet S1, S2, S3, S4. Okay, this one. Okay, now I should adjust this graph and double click this one and quick layouts. This one fine. There is a legend at top, site and top headings, axis description. This one is the mine. Okay. Let me first remove these dots. How I am going to remove these dots? I have selected a graph which is having a line and with its markers too. So if there is some markers description and I am going to remove those markers, none marker, then automatic markers, and these are your markers data points. You can change the markers shape. Fill with non-filled. Markers cannot be removed because we have selected data chart which is having markers, so we have to go over here and we have to go scatter, and this is markers and with no lines, and this is line with markers, and this is something. Let me delete this one. We have removed the data points, and now I should be adjusting this formatting. This is line and its color is blue. It is solid line, not automatic, it's solid line, and let me make it color red, and its width should be increased to 3 points. No difference it makes. Okay, you can change its dashes to this one. Let's look at this one. and more you can write over here is force kilo. Okay, force is in Newton, and this is displacement in millimeter. Let me change its font. Font style should be bold and it should be almost 12. And let me change it to area. Okay, that's fine. Let me copy the style to this one, and I'll go to home, select this one, copy format, and place it over here. Very beautifully, very easily we have changed that. And one detail of the graph, look at this, that this graph is starting from 0 and ending at 0.7. Okay, I can change it to 0.7 is okay, fine. You can change the coordinates too. For mate axis 0.7, you can make it 0.8, and major axis you can move it to 0.2. You can see 0.2, there is a difference between 0.2. When you can make it 0.5. Just look at it. Okay, let me reset this to and this is good. Let me change its font, bold, and it should be Arial. Okay, now I should be writing over here .45 water to cement ratio. This is our heading. Let me change its font. Okay, this is fine now. Let me add some new series, more series. Add, this is your previous series, and add S2 sample S2, and x-axis should be this one, and this is your force value. Okay, that's okay. Okay, let me copy this format. I'll not be able to copy this format. It's the graph. So let me edit it. Okay, very fine. Axis has changed. Okay, it has reached 0. This is not fine. Axis option, and minimum should be 0. Its minimum is -0. So, okay, now it's fine. Very beautiful. We should reduce its font size. That's fine. Okay, let me make a border. That should be black. Now see, there's a border and this is black. This should be bigger. Alright, that's cool. Let me add more series. X and this is your Y. Okay. Okay, this. This color should be, I think it should be red. That's fine. Add another series. Sample S4 and X values. And Y values. This one. Select the whole line, increase its thickness. Okay, this solid line is far better than these dotted lines, so let me change them to solid line. Okay. these lines you want to show, or it's up to you. You can increase the distance too. Okay, now this is fine. Now let me save it. Save it. Save. Publishing. So this is your result. This is your result, and with the help of you can see that you can select the Word document. And very beautifully you can insert screenshot, screen clipping, and this is your borderline. Make sure that your borderline is inside, and select. That's it. Very beautiful. You have received your graph. You can show small, you can make it smaller or larger, whatever the case might be, or you can refine it and that coloring correction, and you can also add some caption, insert caption. Okay, you can insert caption over here, and that's it. This will be a part of your thesis or report. This will be drawn with the help of using Excel. Alright, now thing is like this, that I will be sharing this Excel sheet with you, and I will be removing these charts, and you have to play around with these Excel sheets, and you have to draw different charts and make comparison from them, and moreover you can extract the peak value. Okay, how you are going to show the peak values, this is also interesting part. Let me show over here this point. This is when you hover it, you will get the point. So any specific point I want to show, how I will be doing that. This one, this is your point data label, and what's its value? Get data call out, and that's fine. This data label is just showing the peak, so I should be just running call out. Okay, first delete the previous one and this peak one, and call out both are shown. Then you can increase its size. So copy this, paste over here, and then paste over here. So these are your data points, and now you can draw a comparison regarding these one, how you are going to compare on F1, S1, S2, S3, S4, and this is x-axis and this is y-axis, or you can say that displacement, and this is force. S1, copy it over here, paste over here. 0.2675, 2.7612, 0.2164, 2.27503. S3 is 0.1951 and 1.72767, and S4 is 0.1816, and this is 1.5357. Make sure that there should be some legends. Cool. Okay, add legends. This is important. Which series is showing which sample? Should be this one. So blue line is showing F2. Sorry, it should be edit S2. Make it that series should be showing their corresponding values. Let me delete this one. And now insert, and let me select this one. Bar chart. Add comparison. this is displacement. Very attractive type of graphs you can make and change the color. Here are different options. Chart title. So whatever the case it might be. So very good, and you can copy this and paste it in your word sheet. Okay, the beauty of pasting directly is this, that by double clicking you can directly edit these graphs rather than taking a picture, so this will be editable. Okay. So that's it for today, and we will be looking into more interesting, and we will be using another software, that is Origin Pro, in our next lecture, and that is quite more refined graphical software. So thank you. Assalamu alaikum.